This video is going to look into a little more detail into the Bohr model of the atom, which is the one that usually looks something like this. And although we know this isn't 100% accurate, we still use it to explain a lot of things. The first part is that electrons are found in specific orbits around the nucleus. So you can see the electrons here orbiting around the nucleus. The next part is that each of these orbits has a fixed amount of energy, and that's why we call them energy levels. So each of these dotted lines represents an energy level, and where they are determines how much energy they have. So these smaller ones closer to the nucleus are going to have lower energy. And the bigger circles farther away from the nucleus are going to have higher energy. And the last part is that these electrons are not contained within that same energy level. They actually can jump between the different energy levels. For example, this electron right here is in the lower energy level, but if it wants to and it has the energy to, it can jump and relocate to the higher energy level. But it can also decide that it wants to jump back. And there are actually names for where the electron is. So if the electron is closer to the nucleus or lower to the ground, we call it the ground state. So I like to pretend the nucleus is the ground, and the closer it is to the nucleus, that's going to be the ground state, so the lower energy levels. And if it jumps up higher, then that's going to be its excited state. And that's whenever they're in those higher energy levels, that's what it's called. So when we have an electron that starts in the ground state and jumps to the excited state, that's going to have a name. It's going to be called absorption. And the reason it's called that is because the electron has to absorb energy in order to do that. So in order for it to absorb energy, some kind of energy has to be added to the atom, and that's usually in the form of heat. The opposite of this is whenever we have an electron that starts out in the excited state and then jumps back down to the ground state. And this has a name as well. It's going to be called emission. Sorry, there's only one M in that. There we go. Anyways, the reason it's called emission is because the electron has to emit energy. And typically, this is the order that it goes in. The electron has to be added heat in order to make the jump and absorb that energy to jump to the higher energy level. But when it gets up there, it's not really stable. So we call this an unstable electron. And I like to think of it like the electron is scared of heights. It doesn't like to be farther away from the nucleus. It doesn't like the excited state. So it's going to jump back down. So what happens is instead of all that energy that it just absorbed, it has to emit. And when it does this, it's going to emit light. So the energy that it absorbs was in the form of heat, but when it emits it back out, it's going to be in the form of light waves. And there's a specific name for these kind of light waves called photons. And a photon, the best way to explain it, it's just a little packet of light. In order to understand this a little bit better, we need to know a little more about the electromagnetic spectrum. And you're going to watch a separate video on this, but for now, just know that the electromagnetic spectrum is a way to organize the different kinds of light waves, because light is actually a type of wave. And if you picture a wave, you can see that some waves, like down here, are a little bit different from the ones that are down here, and it has to do with their wavelength. And some waves have longer wavelengths and some have shorter wavelengths. So the spectrum organizes them. And you have one in your reference packet, and it's down here on the very back, page 8, that looks like this. And you can see that it's organized from longer wavelengths to shorter wavelengths. So you can picture it kind of like this. Longer waves, and as we get farther and farther over, we get to shorter waves. And a lot of these waves we can't see For example, we can't see X-rays or ultraviolet rays or gamma rays or infrared or microwaves or radio waves, but the waves we can see are called the visible light range. And these are all the colors, the whole spectrum of colors that you are able to see. Red, orange, yellow, green, blue, violet, and everything in between is contained just within this tiny portion of this whole spectrum. So when an electron is in the excited state and it jumps back down to the ground state, it's going to emit a kind of wave, and the length and size of the wave depends on the amount of energy that was emitted. And what we're going to do is learn how to find that on this spectrum. Make sure you watch the next video that explains a little bit more about what the electromagnetic spectrum really is.